In this video, we're going to go over direct variation, and we're going to see how that applies to functions. Direct variation is in the form of y equals k times x. That's saying that y varies directly as x. So y and x have a constant ratio, and this k is known as the constant of variation. Let's take a look at this when we know what k is equal to. Say I give you the equation y equals 2x. This is direct variation because it's in the form of y equals kx. The constant of variation, k, we know from looking at the equation, is equal to 2. Let's do a t-table with values of x and y and then plot those. If x is -1, -1 times 2 equals -2. If x is 0, 0 times 2 is 0. If x is 1, 1 times 2 is 2. And if x is 2, 2 times 2 is 4. Let me go ahead and draw out our coordinate system, and then I'll graph those. So you can see I plotted the points from our t-table, connected the line, and this goes on forever in each direction, so I added arrows to the end. Looking at this, you can see that if we use the vertical line test that we learned in the last video, that this equation is indeed a function. So y equals 2x can be written as a function. F of x equals 2x. If we change this constant of variation to say 3, 0, 0, but now if we had 1, 1 times 3 would be 3, -1 times 3 would be -3. Drawing that new line, you can see that as well passes the vertical line test. And so on. We could do 4x, 5x, 20x, -10x. Let's go ahead and try 1/2 x. And I'll already tell you that it is indeed a function. So direct variation, in a linear sense, is always going to be a function. So in this next example, we're saying that our constant of variation is 1/2. So k is equal to that 1/2. Again, let's do a t-table. But instead of x, y, we're going to be using x and f of x. And let's choose some values that we're going to use for x. I'm going to say -2, 0, and +2. What that's saying is that we're looking at f of x when x is -2. So we're looking at f of -2. We're going to be looking at f of 0. And we're going to be looking at f of 2. So what we're doing is just plugging those x values in. So we're doing this the same exact way. I'm just writing it out so you can see. So that -2 is going in for x. So that's going to be 1/2 times -2. 0 is going to go in for x. So that's going to be 1/2 times 0. And 2 is going to go in for x. So that's going to be 1/2 times 2. 1/2 times -2 is going to be -2 over +2, which we know just to be -1. 1/2 times 0, anything times 0 is 0. So f of 0 is going to be equal to 0. 1/2 times 2 is 2 over 2, which we know to be 1. So f of 2 equals 1. Let's go ahead and plot this now. Remember, our y in this case is our f of x axis, because all of these are functions. So when x is -2, f of x is -1. So we're going to go 2 to the left and 1 down. When x is 0, f of x is 0. And when x is 2, f of 2, so the function of 2 is 1. And then we're going to go ahead and connect those. And this line represents the function of x, which is equal to 1/2 times x. And again, you can see that this will also pass the vertical line test. So it is indeed a function. So direct variation cannot just be written as y equals kx. It can also be written as the function of x equals k times x. X being our independent variable, as x changes, f of x, or y, is going to change.